Okie dokie, new chapter. So pause and copy, pause and copy. So infinite sequences. Why do we care? Why? Well, we're starting down a path that will lead us to a study of compound interest. A very important topic, which can be described in the following quote. So if you don't understand it, then you end up paying it, according to this person, which may or may not have been Albert Einstein. This quote is disputed. Anyways, the sense of it, I think, is clear. It's a very important thing to understand, compound interest. Now, so we're going to start by studying sequences. Now, a sequence is described in kind of fancy language here. To simplify, what we're just talking about is, some numbers in a definite order. Okay, so positive integers, that's just saying we have first term, second term, third term, fourth term, and so on. So we can use a variety of notations. You can write this, or you can just drop the brackets, or even add more to the brackets. Be more specific if you need to be. A variety of things are acceptable. Okay, so for the example here, you start with A1, okay, the first positive integer, and you're just plugging 1 into this expression here. So you get 1 over 2. And A2 would be 2 over 3. A4 would be 3. Oops, why did I skip 3? That's odd. A3 would be 3 over 4. And then put a dot, dot, dot. Or you could give this using the brace brackets. Half, 2/3, 3/4, maybe one more term if you feel like it. And then put a dot, dot, dot. Once the pattern is clear. And why don't we try an exercise? So pause, copy, try. Now what am I going to get? I'm going to get, excuse me, I'm going to have, I got 2 pieces here, right? I would separate them. Maybe focus on the n squared first. So I get 1, and then 2 squared is, what is 2 squared? 4, right? And 9, and 16, and 25. Dot, dot, dot. Okay, that's the n squared term taken care of. Now, this is what's called an alternating factor is the right term, alternating factor. So because it's going plus, minus, plus, minus, plus, minus, plus, minus, it's alternating back and forth. Now, when n is 1, yeah, this is negative. So I put a negative here. But then when n is 2, it's positive, and it's negative, and it's positive, and it's negative, like so. If you want, you don't have to do this, but just to emphasize, you could actually label these terms a bit more carefully if you want to. Okay, that's easy enough for writing down some terms. Oh, I forgot to close my bracket. Okay, so here we're giving you the nth term. Okay, an is equal to -1 to the n times n squared. In my next example, I'm going to go backwards. I'm going to start. So pause and copy. So in this one, I'm going to go backwards. I'm going to be given a sequence, and I'm going to try to find an expression for an. So this requires a bit more ingenuity. How about the first one? What do I notice? This is 1 squared. This is 2 squared, 3 squared, 4 squared. Okay, so certainly I have a n squared. And then I have this alternating thingy here. It looks very similar to what I just did, right? Looks very similar to this up here, but what's the difference? The negatives are in different places. So I should take a peek at what this was. Up here I had this expression, so I need to modify that. So what I'm going to do is I'm going to change this exponent to n plus 1. Okay, now I have a candidate. I should just double check. Okay, I won't do this, but what I do here is plug in, say, n equals 3 here. What do we get? I'll do it. -1 to the 4 times 3 squared. That is 9. And that is indeed what appears as the third term over here. Okay, so this is often how I do it. I do a kind of educated guess, and then I maybe check a few terms. Next, these are even numbers. So even numbers are easily described as just 2n. Okay. So odd. Maybe in a thought bubble here, I'll say the odds would be two n plus 1 or 2n minus 1, depending on where you're starting. Okay, last one. I got two things happening. I have a numerator, and I also have a denominator. Different things happening. So you want to divide and conquer one thing at a time. Look at the numerator. You know, I've been around the block a few times, so I noticed that this is 1 cubed, this is 2 cubed, this is 3 cubed, and this is 4 cubed. So on top, I'm going to have n cubed. On the bottom, the numbers are increasing by 2 each time. So 7 plus 2 gives me 9. 9 plus 2 gives me 11. 11 plus 2 gives me 13. Okay, so for this reason, I'm going to start with a 2n. Now, that's not going to work, right? Because when I plug n equals 1 here, I don't get 7. So how can I fix this? So the 2n is good, but it's not complete. So what I just said, when I plug n equals 1 here, I get 2, but I want to get 7. So I can fix that by throwing a plus 5 here. Okay, so again, I started with the 2n, and then I had to adjust it. Okay, this is a common tactic. Okay, now I would probably check. If you plug in 4, you get 64 over 13. That is, yeah, indeed, what's going on there. Okay, so it's a bit messy, I'm kind of doing pattern recognition. I'm coming up with a candidate, and often I'm doing little adjustments. Little adjustments that come about because maybe I do checks that don't work out. Okay, exercise. Pause, copy, give it a try.